Okay, so we are recording and I'm going to share my screen. So the idea was to start talking a little bit about Salome Meca and to do a very quick example. And the first thing that I want to say a little bit is about the modules that are available. So we have the geometry module where you would start by creating a geometry, or you can even import some type of geometries. Then you would move to the mesh module, where you would discretize your geometry. And in the last years, they have also developed Shaper, that is a new geometry module that has also some constraints and lets you, let's say, parameterize the geometry. But I'm not going to talk about it today. And usually when you have the mesh, then you move to a test study. This is also a new module with the graphical user interface for all the commands of Codaster, let's say. And we will see the example. And then you would move to Paravis to view the results, to visualize the results. And there are also some other modules, but I just want to say also that OpenTerms is an interesting module that you can do some probabilistic analysis, and you can do various interesting things, but also today I'm not going to talk because it's a bit complex. So I'm going to start with a very simple example, and I'm just going to create a face that I'm going to put here. Okay, so let's say that I have a plate, some sort of a plate, and I'm going to click apply. And then I want to create a pipe. So in order to do that, I will select the center and the orientation along the x-axis. And let's say that I'm going to put, I'm putting some random numbers, but it's not important. Okay, and then I'm going to extrude this circle to make a pipe. So along the x-axis, and let's say this is something like that, or maybe, okay. So we have these two elements. And now when so we want now to make a single object that we're going to discretize after. And in order to do that, the simplest command, let's say, that I recommend also for anybody that is new to this is to click on partition. So essentially, you're making a partition means that you are binding everything together. And then the important thing, you have to start creating the groups. So creating the groups, the group names are the ones that are going to give you the reference for the geometries that you're going to use for the command file then that you're going to create to do the analysis. And so I'm just going to, here you can select the type of geometries. I'm going to select the faces. Let's say that I select all the faces, add. And I just select a name, let's say faces. And then I'm going to select the geometries that I want to apply the boundary condition. So I'm going to fix the edges of this face. And let's say that I call this edges. Apply. And let's say that I want also to define another edge where I'm going to apply a load. So let's say edge number 2. apply and close. Okay, so we have the partition with the groups here, and let's say that we save this document in an example folder. And then I move on to the second module, that is the mess. And I'm going to create a mess. And here I have to choose the discretization, the messing algorithms. And there are various algorithms. I'm just going to use something that is pretty general, let's say, and can get you started. So let's say I'm going to use 20 millimeters, let's say, quad dominated, and a wide discretization. So I'm selecting the algorithms for the 2D and the 1D. So a local length of 20. Okay. And once I have this, I can right-click on the mess and click compute. And this is going to give me this mess. The next thing is to create groups from geometry. So we want to bring the groups that we created in the geometry. So we're clicking here, and then we can also add these groups as nodes, depends on what we want to do later. So let's say that we do something general like this. And at this point, I have the mess, which I can export it, for example, if I want to use it later. But or if you are going to use a command file, let's say, so you have to make reference to to the mess, so you have to save it. But since we're going to use the AsterStudy graphical user interface, we don't have to save it. So we're here and we start the model, and we're going to add the stage. And the first thing that we want is to read a mess. So these are all the commands here that you can use. One thing about Codaster is that it can help you learn a little bit of French, and this is not bad always. So we have to give reference to the mess, and I'm going to find here, this is a list from the mess module. Otherwise, I would have to click here and import the mess. In this case, I'm just going to import it. Okay. And we have, we have our mess. Okay, yes. And the next thing is that we want to create a model. So we want to tell him, to tell to the program what kind of analysis we want to do. And here we have to select the groups that we want, or in this case, we're going to say that everything is going to be on this model, and it's going to be a mechanic model. And I'm going to have to select what type of elements, of cell elements in this case, I want to consider. So these are the DKT is one of the simplest elements, let's say, that we can use. And then I'm going to click OK, and we have the model. And then let's say we have to create the material, define a material. And I'm going to use the simplest material. This is a linear isotropic. And I'm going to use steel. I'm using megapascal, Newton millimeters. So say I'm going to use this, and then the density, this should be in, let's say, Newton divided by the acceleration of gravity per millimeter square. Anyway, this is the value I'm going to use. So we have now the material that we created. And the next thing is to assign this material. So here, again, we select in which model we want to assign it. But okay, now we have just one model. And then we assign this material, so we can see also here in which groups we want to assign it. So in all the faces, we want to assign this material. And this is the single material that I have, okay. Okay, so we have assigned this material, and the next thing is to assign, to create the element. So this is the command in French. So we are going to give essentially the thickness of the cell, and the coque is the cell in French. So again, we have to give him a group of elements, in this case, faces. And we have to give him the thickness. Let's say that we have 20 millimeters. And then we have to give him an orientation vector. Essentially, what we're doing here is that the program will project this vector on the plane of the cell, and this will be the x-axis, the x local axis. So when you are looking also for the forces or the stresses that they have reference in local axis, you know where is this local axis x. If you don't define it, then it's going to be by default along the x-axis, but it should not be perpendicular to any face. So in this case, for the plate, it will give us an error, so we have to assign it. And by doing that, we have also the element. And the next thing is to create the boundary conditions and the loads. So you can do this from this command. So I'm going to tell him that I want to enforce some displacements, and I want to give him the groups. So in this case, we use the edges that we defined before on the boundaries of this plate. And I'm going to say that in these boundaries, I don't want to have a displacement. So displacement there in the 3 directions is 0. And by this, we have defined the degrees of freedom. Then we can also, let's say that we define the gravity load. So we have to go to gravity, a minute. Yeah, gravitational load, okay. And I am in millimeters, so let's say that the constant more or less is 10,000 millimeters per second square, and the direction is along the minus z-axis. And to finish, I'm going to apply also a force on the other edge. So a linear force. This would be Newton per millimeter in this case. So again, I select the group that I want to apply it, and the direction, the force, let's say that I'm going to say minus 10. So it's in the same direction. Okay. And every time I do these commands, here you see the command written, let's say, in the language of Codaster, that is Python essentially. So every command has could be reproduced by a Python file that has this code. And then we have to move on to the analysis and to run static mechanical analysis. And we have the material field where we assign the materials and where we assign the elements. And we have to tell him which loads we want to consider and boundary conditions in this case. So in this case, we have just one because we have everything there. Okay, let's save. And the last step is to export some results. And for this, we have to use set output results. And here I have to give him a file name, let's say result dot, and the extension has to be rmed, which stands for results med. Med is the native, let's say, mesh file of Codaster. And I have to define what kind of results I want to see. I'm just going to be very brief, and I'm going to tell him to export all the components. So everything that is going to be on the results files. Okay, so we have done something wrong. You have no. Okay, yes, I have to select which result. So I have the result, the mecha static, and I'm going to tell him all the fields to sum. Yes. Okay, so we are good to go, and then we can move to do the analysis. So we are here, we can tell him how much memory we want to allocate, but all this will be fine for this. And we click run. And here we have to select an auto refresh so that we know that it's finished. So we see a green light, which is good. And then we move to Paravis. And here we have to import the results file that we have. And click apply. We want also to see the deform shape. Okay, so essentially we have the displacements and some forces in the Gauss points, but let's concentrate on the displacements. And if we click here, this is the common toolbar. We can see the deform shape. We can put here a scale factor. Usually in the middle is good. And we can see how this is deformed. And we can also have the magnitude or any direction that we want this data. And this is pretty much this quick tutorial. I don't know if there are any questions by anybody.
I found that very interesting. I was just wondering if you wanted to model something like welding, to join two parts together. Is there some kind of straightforward method of doing that?
Welding, you mean the actual welding?
Yeah, like say you had that cylinder and it was, like an extruded pipe you'd acquired somewhere, and the plate was a separate part, and you wanted to join them together and then model the strength based upon the joining method. Is something like that feasible?
A lot of things are feasible, although are a little bit complex. I guess you would need a solid geometry, and then it depends what you want to do. I mean, if you have the parts that I saw here that I created in the beginning, so I mean, if you have more parts, as long as you do a partition, then everything is bonded together, and you can, if you are modeling also the welding, you can see the stresses in the welding and so on. If they are not, if you don't use the partition and you use a primitive that would be a compound, then these objects will not be connected, and you have to, in Codaster, you have to use some specific commands, more complex commands, to specify what are the connections between the objects. So, but in general, yes, I mean, it is very powerful. You can do everything that you want, but yeah, it depends on the problem.
Thank you.
I don't know if, okay.
Ioannis, what about, do you find yourself modeling the geometry from scratch in this program, or do you end up like importing geometry from, you know, the architect or whoever, or model it in another program and bring it in here for analysis?
It depends on the problem again. If it is easy to model it here, I will model it. If I can import it, or most of the times I have, let's say, I use some scripts that will create the geometry, let's say, using the APIs, because also everything that I did now, at least for the geometry and the mesh module, they can be scripted. So, for example, if I do a dump study, and let's say I save it here, and if we go to, okay, wait a minute. I think I closed the program. In any case, you can actually dump the study, and you can see how you can use the API to script. So most of the times I'm using some scripts, let's say. I'm sorry now that I closed the program, so it didn't. But let's say that I create this, and then I'm going to dump the study on the desktop. Then I should be able to see the API and how to create what I did. So usually, yes, to answer the question, or I will import, or I will have some scripts of my own to create the geometry.
So like, say for a typical, like say, I don't know, 10,000 square meter building, it's all steel, right? What do you typically do? Do you typically model that steel structure in this program, or do you start elsewhere?
Typically, I would start, let's say, on a CAD program. Let's say I was using maybe also AutoCAD to start the geometry. And then maybe I will use Python, for example, to extract the elements and recreate them with a script.
Okay.
But yeah, I mean, as it is, this program, you have to have some automatization, let's say, procedures, because it is not feasible that you are going to write all the required code by hand, let's say. So you have to have some kind of management, let's say, so some kind of scripting.
I have two questions, Duncan, here.
Is it? Okay.
Yeah.
One of them was, do you have, a bit like what Ryan was saying, with more complicated and larger models, do you have an example of one just on your computer you could open and show us? Just because I like things that look pretty and complicated. And I think related to that is the question of, if the geometry is coming from a different program, how intelligent is that transfer?
For the geometry, no. I mean, if you use, you have this kind of files. So can be edges or step or brep. Yeah, maybe I can open something. Let me see.
Yeah, I don't really know anything about those file formats, so I'm also kind of wondering the whole issue of the types of loads and the type of physical characteristics of a geometry. Are they well stored in some formats from some CAD packages that work well, or what's the status of that?
I mean, edges, for example, okay, from AutoCAD. Okay, I also tested from FreeCAD, for example. You can export edges and stuff like that. I mean, these are the formats that you have. Let me see if I can open something.
And he
But
just brings over the geometry. Sorry, Brian here from Sydney. Is
yeah,
just geometry, nothing else that comes along with it, isn't it? The surfaces, sorry.
yeah. I mean, these are pretty general geometries. I mean, you can import surfaces, you can import everything, and or you have also STL. I mean, you have two stages, or you can import in the geometry, and then you have to discretize, or you can import in the mesh. In the mesh,
Is there an open format that also includes physical properties and loads?
this, let's say, we are working on the IFC to Codaster, so that could be the next thing, let's say, to show how you can import from Codaster and not from Codaster, from IFC. But it will be only lines, and for now it is only planar surfaces. So these are, let's say, what we have done until now. Let me see. Okay, let's say that. But there is no other open format, let's say, that have everything inside. So also, because these are just the geometries. So there are no loads and stuff like that. If one of the things that from IFC to Codaster is to consider also the loads and everything that are there. Okay, let's see that I want to import something. Okay, so this is, for example, a structure that is bigger compared to what I saw. So this is a structure in CLT, and is created with scripts again. So I'm doing, let's say, some plan views in a CAD program, and then I have some, let's say, extra databases where I give properties to these plan views. And here you can see that there are all these faces that are created. So it is practically impossible to create this by hand, I would say. And this is actually a structure that was tested for earthquake. So it is one of the studies that I did. And maybe you can also see the results. Okay, so I have to go back to the media. Okay, and this is again the structure. So here, for example, we can see these are called the basic modes of vibration, let's say. So we have how the building will move, let's say, the components of the movement.
I think you've got a
So,
problem at the back of the roof there.
yeah, this is just one of the local modes, let's say. So, yeah. So this is one of the examples, let's say, big examples. But as I said, you have to create, let's say, some tools to manage these geometries, because it is impossible to do it by hand.
So, follow-up question. It seems, and correct me if I'm wrong, is that it doesn't seem like it's very accommodating to changes in the pipeline. You know, those pesky architects always want to make changes, right?
Okay.
So, does it accommodate changes in the pipeline quite easily, or would you, if the architect moved the window or whatever, would you ultimately have to just remodel that whole thing basically from scratch, kind of thing?
I would say yes, although now with Saper, with this module, there are some possibilities, let's say, to have some parametric nature, although you would have to define everything. I think that in this case, I mean, if you have a kind of automated pipeline, then you just change something in the beginning. Okay, you have to do all the pipeline, but it can be accommodating. If you create the model by hand, you have to, let's say, make the modification by yourself manually, let's say. But no, there is no, let's say, something automatically, let's say, managed, so that you change something and immediately you see, let's say, you go directly to the result.
Do you find yourself cursing the architect a lot?
No. After I made the scripts, not so much. I mean, okay.
Yeah.
I like architects. I'm not getting in fighting between engineers.
No,
and architects.
I'm teasing, but
Yes,
how it
yes,
goes. In our industry, it just seems that we're trying to streamline the content between all the various disciplines, right? And so the ultimate goal, I would think, for efficiency would be to not have to model something really again, whether you're the architect, structural engineer, the fabricator, whoever, it's just to use that content back and forth. So that's I'm curious on how it accommodates changes.
Yeah. I mean, as long as the changes are well shown, because sometimes there are also architects that maybe just send you a new CAD file, and then you have to find the changes. Okay, as long as this doesn't happen, I mean, it can be okay to modify.
Sorry, I'm curious about the meshing functionality. Seemed pretty quick when you did that small object. There's certain programs that we currently use that takes really long when you try to, I guess, make more meshes or smaller meshes. That seems quite a large structure. And how long does it typically take? We realize that some of the programs, if we do fatigue loading design, your meshes are really, really tiny. It tends to slow quite a few programs down.
Again, I mean, it is it is pretty flexible because let's say that it has various algorithms, and okay, meshing is a big chapter, let's say, and depends what you want to do, but the net gen is pretty general, and it is quite fast, I would say, and you don't have to set so much. But again, it has, for example, the disadvantage that you can get some unstructured mesh. So it is not always, let's say, a structured mesh, although also a structured mesh is not always feasible. I mean, here it is pretty good. Here in this case, the walls, for example, I'm using, instead of the NetGen, I'm using quadrangle mapping. So it also depends on the algorithms. And you can also use GMesh. GMesh is also a powerful meshing tool that it is an independent application, let's say, but is integrated. So you have pretty much a lot of options, and but you have to try them, and you have to see, let's say, what works and what not. So yeah, I mean, it is a whole world.
So you're saying that certain elements you would mesh a different way, and the program should be able to kind of tie them in from surface to surface that's connected quite easily, or do you have some mucking around after that, after you've meshed it, kind of fixing up and touching nodes and stuff like that?
Personally, I never, I never touch after, let's say. So I prefer to have a good, let's say, procedure so that I do the mesh and that's it. You can have, for example, you can have sub-meshes. So you can select some geometries, and you can tell him how you want to be meshed. So in the end, you have pretty much flexibility, let's say, to select some groups that you want with a certain type of meshes. And then it also depends, let's say, how you set up your geometry. For example, let's say that I have two edges, let's say, that they are, let's say, I don't know, let's say these two and the other. I mean, I'm just going to say that sometimes you have to have coincident edges so that when you mesh them, you're going to have coincident nodes. For example, if you want to have coincident nodes, you have to consider some specific meshing strategy. In this case, for example, so in this case, I have all these groups. So as you can see, the white groups are where I have duplicate meshes, nodes. So let's say that here, the wall with the floor, they have, here there are two nodes at the same position. And this is because, for example, I don't want this to be a rigid connection. So I am doing a kind of a script where I collect these nodes, and then in Codaster, I tell them, for example, that I want only the displacements on these nodes to be the same, but not the rotations, for example, because this is a timber structure, so you don't have rigid rotations. And then you can see, for example, that here I have three nodes, because you have the wall, the two walls, plus the slab. So there are all this kind of, let's say, in this model, everything, let's say, is not connected. And but in order to end up, all I want to say that in order to end up with the coincident nodes between all the walls, then you have to to be very specific in how you create your geometry. That's all, because otherwise you're going to have nodes that are not coincident. And in Codaster, you can also, let's say, do that and not have coincident nodes, and then you can tell him to bind these, let's say, edges together. But this is another command that can be more heavy. So usually this is how I work, but it can depend how anybody, let's say, can operate.
Thank you. Yeah, understood.
You're welcome.
I've got another question as well, Duncan in Denmark. Yeah.
Mm-hmm.
The mathematics behind all of this, is this all? And I know I've discussed with some of my engineer colleagues in Denmark. They're saying, they just can't use anything if they can't audit, or if there are not audits of the fact that the mathematics that's going on in the background follows the various ISO and DIN and so on standards.
Mm-hmm.
What can you say about that?
Oh, this, I mean, you mean about the how good is the code? Something like this?
Not how good is the code, but how the
mathematics behind
the
it,
physics
yes.
modeling.
Yeah, because Codaster is developed by EDF, that is the electricity of France, let's say. So it is all open source, and it has a very vast documentation. So all these, for example, are the documentations for each command, and then you have references, and here you have the validation. And then, so let's say, and they have more than, I don't know, 1,000, 2,000 tests. So I don't know, the reference is exactly the mathematics behind it, for example. I don't know, let's open something. So you can find anything, let's say, everything that is on the code. So from that point of view, it is very strong. As long as you have the time to read everything and verify by yourself. But the whole, let's say, theory is written, everything is written, and they have also a validation from the French nuclear authority, a certification. So because they use it, let's say, for various studies in their projects, industrial projects, nuclear projects. So from this perspective, it is very strong.
Sounds great.
I have a question real quick. Is the, I'm always having issues of wanting to use some sort of novel material or, non-standard product or natural product. Would a program like this help with that, or is it mostly it's really set up to use standard products that have all the information already set up about them?
You mean about the materials that you can consider?
Yes.
No, it is very general again. I mean, it has a lot of materials for 3D, for 2D, and it is very general as long as you have time, let's say, to understand how everything works. But there is also external tools that you can use to program, let's say, the law that you want to model. So there is mFront, for example, that is a general library that it is also integrated in Codaster, where you can actually write all the physics about your material and define your own material. It's not very straightforward, but I mean, the capabilities I would say, very, very, very big.
Thank you.
You're welcome. Yeah, just to show here material, for example, define a material. And so basically you have all these types of materials on the right. And this is just a few, or not a few. I mean, these are that are inside Codaster. But yes, it is a very general from that perspective. Are there any other questions?
Yes. I saw that there is some water turbine on the website. Do you have some samples for hydraulic stuff, or?
For hydraulic stuff, no, I don't have samples, to be honest. But maybe, I mean, because
Yeah.
they have a lot of the test cases, as I said. And here in a stealth study, you can import test case. So, I don't know. I'm just going to say that if somebody looks on the site, the test cases, then you can find all the files related to the test cases, and you can maybe have an example to see how it is done. So in the documentation, if you go to the version 14, for example, and test cases by name. So here you have all these test cases, and if you find something interesting, all these are files, let's say, that you can import and you can use. You can recreate, let's say, they have already the geometry, they have the command file, and so on. And just to say that it has also capabilities about the thermal analysis. So you can do thermal analysis. You can have the material properties that are a function of the temperature and all this kind of stuff.
This is really impressive.
It is
25 years old. Okay.
Yes. It is 25 years that they have open sourced it, and you have the Python, let's say, API.
Do you use this program daily in your practice, or is this kind of a one-off thing?
Daily.
Daily.
I use only this program.
Okay, cool. Well, that's good to know. Yeah.
Yeah, I mean, we started when we started the company. Let's say because for Timber there are not so many software that, or at least 5 years ago, and so the idea was to start, let's say, using something that we could build upon. I don't know if there are not any other questions. I mean, or we can stop here if we want to have some other discussions, or I could also show something about IFC to Codaster, but it's up to the group. I mean, there are also some other things to discuss. I was thinking to take less time, but with all the questions, let's say. So I don't know who is interested to see also IFC to Codaster, or we can move with the next topics maybe.
I would be interested in that personally.
Sorry, just jumping in. Just in case people don't know, Ioannis has created a page on the OSArch wiki on how to learn Codaster and Salome Meca.
Yes,
so
that is a very good.
I pasted it in the chat if anybody wants to take a look. This is way above my head. It's very impressive, but maybe somebody more technically minded can understand it.
That is a very good catch because I forgot about it. So yeah, in the wiki, I collected a little bit of materials for Codaster. So there is the book by Jean-Pierre Aubry. This is one of the gurus. And some video tutorials. We also are doing also our video tutorials, but I included more, let's say, everything that I found that was interesting. And then a little bit about the official documentation. And there is also a website for the Codaster Italia. Thanks, Dion, for this.
Just thinking about your question of IFC to Codaster, I think the work, it might fit very well with one of the things we were going to talk about just briefly today. Well, I don't know how briefly actually, but this whole business of round tripping and how good we can get at data moving between platforms. I don't know if those, because at the moment we haven't. Does that deserve to be a topic for itself, so that we can take that whole discussion in one go? What do you guys who are working on the round tripping MVD thing think? I don't know how much.
Sure. Well, I guess I can comment on it, or just explain briefly what it is, and Yorick can step in here as well, because we basically started this thing. It started basically. What?
Just before you do that, Ryan, I'll put the link in here. One of the issues we've got on the agenda is to look at this mission statement. So I'll just put a link. I've put a copy of the mission statement up on an Etherpad. So I'll put that in a link. So anyone who hasn't read it and would like to read it before we talk about it, I've put that link in the chat.
Okay, cool. Well, I'll briefly describe this project and whether we want to chat about it now or later or not at all. Leave up to the group. But it's basically a set of experiments that Yorick and I have started a couple of years ago to explore how well certain objects can round trip between Revit and FreeCAD via IFC. And we try to break it down into the simplest objects initially. It's been a couple of years, but we're still kind of working out on simple objects like, extruded objects, material names, round tripping, families or groups or mapped items are called, or cells or CAD blocks, many different names and different programs. But just to have these experiments where we're trying to round trip to try to get to a small subset of objects that do really round trip well. And so far, we've kind of narrowed down just a very few set of objects, but it allows us actually to entertain certain workflows. And those objects right now are basically simple extrusions and material names. And what we've done with that is that we've modeled objects between FreeCAD and Revit, and we've round-tripped this content, and we basically created small-scale construction details. So where you zoom in very far, and it's actually three-dimensional models, and obviously it retains the extrusion information and also retains the material name. And so what we've done on the Revit side with that is we've taken the material name and basically applied a tagging script that basically pulls that material name out of the objects and creates a tag on it. So I guess in a high level is that even though we have a very, very small subset of content that we're able to round trip between these various programs, we're able to find a viable workflow that we can kind of entertain this. We don't need all the bells and whistles, all the BIM out there, but just a certain subset. So the idea hopefully would be to just keep expanding that subset over time and adding more intelligence and also to expand the ecosystem of BIM programs that are able to do this. So Blender BIM and ArchiCAD and whatnot. That's the ultimate goal, would be to have it be very agnostic. So we'll see where it goes, and that's ultimately what we've been posting on the forum, is just trying to get others to help us run these tests and to suggest various tests and what to do next. So that was in a nutshell, I guess. York, I don't know if you want to add anything. You've been in there since day one too, so.
I'm really curious about what the challenges are, not just with this workflow, but what the challenges are in general, and what you guys think the limits are of all of this.
I'll let York speak.
Okay, my turn. Yeah, basically, it's basically what Ryan said. Sorry, it's a bit dark here. Yeah, basically the idea behind the round tripping at first is that you would export your model to IFC and re-import it back in the same application, and you would get the same model as you had before exporting. Obviously, this never work anywhere because there are too many particular things of your application that are not supported in the IFC, and so you always lose something. But what we're trying to do with that round tripping is to sort out what we can lose and what we don't want to lose. What information is important to keep, and that's what we're trying to, let's say, okay, this works, this works, and for example, yeah, if we have objects that are extrusions, they kind of work everywhere. If we have materials and that every application can read that material back, okay, materials are covered, and we try to go that way and try to find out what we can have in an IFC file that works, exporting and re-importing back. And so we begin to build a model that is trustable and where you know what works in it, basically.
Are you guys creating importers and exporters as part of this process, or are you guys just using the stock standard stuff that you're importing and exporting IFC with? I mean, yes, you'll know what particular platform like FreeCAD or Blender BIM that you're exporting your IFC as.
I can say from the Revit side, no, we're not, or no one's basically stepped up to help. As you probably maybe know, Revit has an open source importer exporter out there, and I've submitted a number of issues to the issue tracker on GitHub to request help on certain things, but no one seems to pick up the baton. From what I gather, it's the open source importer exporter is pretty baroque and convoluted, and it's hard for really anyone to get their head around. There's probably 3 people in the whole world that maybe know how to dig into it. But York and Dion obviously can speak to this. They have, by the beauty of their platforms, worked on improving the importing and exporting to improve the fidelity of the transfer. Yes, and the one thing that excites me is that I started working with York a long time ago and trying to exchange content via IFC, and my hands are tied, but his are not. But now with Dion working on Blender, now I'm kind of less, I care less about trying to fit Revit in there, because ultimately what I care about is the in-between, is that, developing some translation between programs. And if you can demonstrate that, then I think other programs will jump on eventually. So that's the exciting aspect of me in the last whatever years is seeing that exchange between Blender and FreeCAD. Because yes, now, because you can get under the hood, you can improve that fidelity. You can demonstrate it to the world, and I think everyone wins.
I think, just jumping in here, one of the most complicated things with this is that, yes, you can solve it for Revit. And I actually have solved it for Revit. It was clunky, but I have managed to round trip it between Revit. I have been able to round trip it between SiteCAD, for example, or another program. But that's sort of one-offs because you're writing the code to accommodate for a particular other vendor's style of authoring IFC. If you wanted to solve it for all programs, and that's what I'm trying to do now in the Blender implementation, it requires you to import the IFC data as is. And the problem is that many existing platforms find it hard to translate the IFC data. So for example, materials. IFC has the concept of a material which is being assigned to an object, but then each object may have different items in it, each of which have a material of its own. And some programs just don't understand this fact. So for example, in Blender, it will work because in Blender, you can have what's called a material slot. So a single object may have 10 materials assigned to it, some of which is assigned to particular portions of the object and parts of it which are not assigned to anything. Whereas Revit doesn't have this concept. In Revit, you cannot have a material which is assigned to an object, but not to the object's shape, if that makes sense. It doesn't differentiate between a material just being assigned to the object and a material that is assigned to a particular surface of that object. And as a result, there's a huge amount of work to be done internally within Revit to support that paradigm. But that's just one example. Extrusions is the same. You can round trip an extruded object, that's easy. But what if you have an object which is made out of an extrusion and a faceted B-rep at the same time? And so your importer then has to understand that a single object can be made up of multiple sub-objects, some of which are parametric, some of which are not. And in some programs, it accepts that, it understands that a bit easier. Some programs, less easy. So it's just a bit of a challenge. But that's okay. We're working through it. And there's a lot of rework to be done, unfortunately, because, for example, both FreeCAD and Blender use IFC OpenShell. And IFC OpenShell is very good for turning everything into a mesh so that you can parse it easily. It's very good at iterating through geometry, but what we're trying to do is a lot more fine-grained, and as a result, many of the nice, convenient functions in the IFC OpenShell library, we have to rebuild in a much more fine-grained way. So I hope that makes sense.
Yeah. I think the beauty of this whole round tripping project or experiment is that it forces you to be stricter in your implementation of the exchange. Is that with other MVDs, right, the reference view and the coordinated view and those other ones, right, there's a lot of ambiguity there, right? There's upon import or export, there's a lot of ambiguity. But with this round tripping, our point is to be very strict on ultimately what the other party is receiving, and that it checks out and everything, that it can be somewhat easier, right? Because it's like it just, the fidelity of it really needs to be there from everybody's perspective. And right now, obviously, there's only just, a few things that we can do. But with those few things, we're able to, I'm able to, or we're able to use it in actual projects, right? That's a beautiful thing. Like, we don't need all the bells and whistles. We can do simple extrusions, and we can actually work on a third of a project, right? And it would be nice to like dial that up over time, is to improve that fidelity. And next thing you know, we might get into round tripping intelligent walls with windows or whatever. But yeah, I'm excited about just, a lot of the hangups on IFC too is just the implementation is just too open to the whims of the developer or whatever. And so it would be nice to see whether this or another project to see just a real strict implementation of it and see what that gets us. And maybe that's not possible, but
maybe the next monthly meetup we can demonstrate and talk a little bit more about round tripping, because it is a big topic in itself.
That's interesting. So you guys have in this community open source programs that do parametric modeling, and open source programs that do structural analysis, and also potentially I guess drawing production, what have you, to then prove that you can round trip, not only structural modeling for drawing production and also structural analysis, transfer of information through IFC. So is that the end game? And once you can prove that, then hey, all the other software developers then are lagging behind in terms of true interoperability.
Oh, they're already lagging behind in interoperability.
Yes, sorry. Yes, but you guys are creating something here with the open softwares that can then really demonstrate that even complex objects, that we can actually do that.
On a related note, would I be able to jump in and ask a question of you guys? I think it's kind of relevant. With the IFC stuff, I'm not coming from the industry, so I don't have the background there, but coming from software, I understand the benefits of models. I would assume that for a large commercial type project, this sort of stuff is used to generate copious documentation and approvals and do site planning for materials and all sorts of stuff. Is there a list somewhere of actually executed outcomes based on these models, like the sorts of things that it is used for? And then is there a smaller scale achievable subset that maybe would be useful in smaller projects?
Are you looking for workflows using open source software, or is that a general question about what happens with all this geometry?
Well, just about IFC use in general, and with open source. Is there like a list of successful, outcomes or demo projects or something?
Yeah, one interesting way to look at it is also in the government requirements. If you look at the IFC article on Wikipedia, it has been there before. I assume it's still there. There's a list of the requirements in different countries. For example, I know that in Finland and Norway and Denmark, and I think Germany and a number of countries, certain types of projects, it's a requirement. You have to deliver an IFC. I haven't heard of any countries where there are requirements that you have to draw your documentation from the geometry represented in an IFC file, or that your quantities have to come from IFC data. But that's what it's used for. The problem is, like Dian was saying, it's fine maybe that you can generate your drawings from a quite detailed Revit model, but the version of the model that you get when you export it to IFC is not always quite the same. It's a lot better now than it has been, but it requires some massaging. Is that the type of thing you're asking about?
Oh, not really. I just wondered if there was a list like on the web or something of actual outcomes from all this modeling work. That's all. That could be applied either, in the open source space to something larger or maybe to smaller projects. Is there like a functional outcomes goal list? I guess that's the question.
Well, there are example like Building Smart. Have you heard Building Smart before?
Never.
It's the international body basically that manages IFC, and they have yearly awards. They give awards out of companies or projects that demonstrate or push the envelope of IFC use or open standard use in the building industry. And so I don't have a link on the top of my head, but on the website, I'm sure you could say Building Smart, past awards or something, and you could actually read documentation on how various teams have used that to coordinate and collaborate with each other.
Okay, thanks. I'll have a look at that.
Sure.
I think one other thing is I don't think anyone really has a list because the industry is just so big and there's so many varieties of way people want to use the data. But there are some which target IFC a bit more. So for example, COBE, which is a standard for what data you should include so that your model can be used for facility management, which is pretty big in some countries. That does have requirements. For example, you must store your data in IFC format, and here is a suggested list of data you must store, which may include things like coordinates or dimensions or material properties or other product warranties or things like that. And it does, as part of the standard, it does tell you where to store that in the IFC format. So that's one example. Another one would be the work that is done by Building Smart in integrating it with GTINs, so that you can track the manufacturing and installation of objects. So there are standards. So Building Smart has a set of property sets, and for example, in one of those property sets, it says here's where you store the GTIN information. Some countries also extend these property sets to have their own standards. So for example, I think maybe I shouldn't say too much. I'm not sure if this is public knowledge, but there are some governments which do have or are developing property sets to say when you submit your models to the government for approval, we expect to see these types of information in it.
Yeah, the Danish state. The Danish state has done something similar, where they say that in your IFC files, when you submit a project to us for a competition, you have to your file has to include this data aligned with this property set. So,
but if you take a step back and just say those are the end goals, but what are the things you need? A checklist of things you need to support to be able to then achieve all of the goals. The closest thing is the table of contents of the IFC specification. If you support everything in the table of contents, then as a result, by default, you can support any end use application. It's a bit ugly, the main page, but I've just posted a link of a table I copied a while back, and that site has the table of contents from the IFC spec, and I've listed what I'm supporting, what I'm not supporting at the moment.
it's already better looking than most of the Building Smart pages. So.
One thing I did want to bring up briefly, simply because a few people are here. Kevin Kress, K. Kress is here. Global Citizen is here as well. There was a discussion that started just over the past few days not just about round-tripping geometry, but round-tripping annotation. So Kevin Kress is the developer of the Measure It add-on, or sorry, the Measure It Arch add-on. I hope I got that right. And that lets you do annotations in Blender. Now, I think, is Steven still here, or has he left? Steven's left. Oh no, he's here. Hello. So there are 3 implementations that I know of right now which sort of bring annotation into Blender, which is Kevin Kress's one on Measure It, Steven's one on the ArchiPack add-on, and the kind of approach that I've taken on Blender BIM. And they're all kind of different and targeting different things. And we were thinking of, I haven't talked with Steven yet, but I was looking at the work that Kevin's been doing and thinking that it'd be a good idea to sort of integrate that. I mean, he's been doing a lot of great work. If the work could be integrated somehow, I could give him the stuff that I've been doing on the IFC side, and he can combine the stuff that he's been doing on the dimension side, then that would be a good thing. But I'm just aware of time. It's nearly approaching an hour and a half, so maybe that was just a teaser saying that this work is starting to happen, but maybe we might have to delay to the next meeting.
It might be that we maybe we can also just generally agree here how long we think the meetings should be, because then we can sort of put some time aside and say, well, let's say that we have a presentation which takes an hour, and then we have these things we've agreed for the minutes, and then we have these agenda points that people have added, and then we maybe have some extra topics that might turn up, because a discussion like this one is really important. But one of the discussions that was on the list that Dion, we talked about was a talk about this mission statement I've looked at. Should we have a quick look at that?
That's right. That was there first. So let's get that wrapped up.
Yeah.
And maybe the rest of the stuff we'll push it to the next time.
And I guess so. The background for that was just that we started talking about last time. We started talking about what we want to spend our time on and what we think is important. And I thought maybe taking a few steps back and trying to get to the heart of, well, why are we all here, and what do we agree on, sort of in general as a background might be a good idea. So I started. Let me share my. It looks like most of you are in the Etherpad thing there. Let me just share my screen. There. You can see it, right? Can you see the Etherpad text?
Yep.
Yeah. That hasn't changed since the one I put up on the forum. And what's this useful for? Yeah, well, that's always a good question with this kind of waffly text. My idea was just to align a little bit and find out what things we agree on and what things we need to talk a bit more about. And I could see, for example, that there's a few different ideas of how much we want to talk about ethics, how much ethics is important to us in this project. And do we mean the ethics of the industry, or do we mean the ethics of software development, or do we mean the ethics of, what would you call it, client-consultant relationships and that kind of thing in terms of transparency? None of the comments that I've got are comments where I think that doesn't make sense with what other people have said. So there's no comments that have come in that I think are going to be a problem to work into this text. But what I was just a bit interested in is, what do you guys think about how much we should write about ethics here? My view is that when I go to a website for some project, I look at eye candy. Does it look like they've got their shit together? That's one thing. And the next thing I click on is the About link to find out who do they say they are. And that's kind of what I'm thinking this is. This is like a landing spot for people who are going, well, who is this bunch of people? What on earth are they trying to do? That's why I think having some kind of mission statement might be good. Actually, before we talk about the specifics of the 2 points I've got there, ethics and AEC and transparency, what do you guys think about even trying to do this? Do we want to do something at all, or do we want something much shorter? I've seen some really good short texts. I've seen a few good, really short texts from people when they've suggested some changes. That's one of yours there, Dion. Maybe we just want a short one. Maybe we don't want anything at all. What do you guys think?
I guess I don't really have a strong opinion one way or the other right now. This was brought up, I think, on a couple comments in that thread, is that, and it seemed to resonate with me, is that we don't necessarily have to narrow down now, kind of thing. It's just that,
sure.
I think, like somewhat like on open source, it's that, people put those opinions out there and there's kind of multiple angles and it's somewhat messy, but someone reading through can kind of understand, okay, I resonate with this or I resonate with that. But, again, I'm certainly on the fence. We could dial in what that is, but I don't really have a strong opinion.
I think it's great. There's a sort of ethics mention. I think that's good to have that element in the zoom out, Duncan. I think that's really good. I'm actually an open source person for a long time. I'm also a Wikipedia admin, blah, blah, blah. So 20 years or so I've been looking at this stuff. I think it's great to have that zoom out thing, which identifies the values. But I think in finishing something like this, which, as you described, it's sort of a waffle, but it's important. But I think maybe a video chat might not be the right forum for tweaking it all, because a discussion is just going to take a really long time. So maybe it would be easier to do it on the forum. But I think it's looking good to me now.
Yeah, we're not gonna. I'm not pretending that we'll agree on a text right here. That's a messy way of writing a text. Yeah, because I'm thinking what we've got. What we've got now is what I regard this as, is now we've got a skeleton with the right bones, and we just need to move some of them around a bit. But the whole thing of ethics, I kind of skirted a little bit around it here in the text. And something I thought about afterwards is maybe I should just go in and look at what the Free Software Foundation and Electronic Frontiers Foundation and look at the way that they've worded some of these issues and bring some of that language in. That was one idea I had. Because for me, I find it a bit difficult to formulate some of the issues that we understand as being the whole basis for free software in the GNU sense. I think it's quite hard to write them in a way that people who don't already understand it can get. But that was the next thing I thought I'd do. Take in some comments and then bring some language in from Free Software Foundation and EFF and stuff like that, and then just put up a new version of this text. And then I would imagine that we're at a level where we can just put it directly on the wiki, and then see if people need to make small changes to it. I would imagine the text is stable enough that it can go onto the wiki by then. And then we're sort of over this vague discussion stage. We've got something we can discuss one point at a time if we need to. Otherwise, it just sits there as a way for people to understand what we're about. Is that sort of where we are? Because I'm not precious in thinking that this should be a big thing that we should spend a lot of time on. I just think it's a good place for people to land and understand who we are. Because reading through that wiki, if you don't already understand all of that stuff, then you're pretty lost. And I really love it if we can get something that just sort of curious architecture students and curious engineering students get bitten by and think, oh, that sounds really interesting. I want to play with some of that stuff. Yeah. So that's where I'm at with that project. I'm getting 1 thumbs up, so that's good. Should I just leave it there? I'll work on that text, bring some of those descriptions of what free software is in from other things. I personally think that this text maybe could be closer to this text. So we've just got something short and snappy. So if nobody screams that that's a really bad idea, then that's what I'm going to do. That's good.
It's good. It's good.
So we've talked. That was the mission statement.
Brevity is king. That's in my opinion. Brevity is king.
Yeah. What I was kind of thinking was this. Oh, now I've clicked on the wrong thing. What I was kind of thinking is this bit is enough for people who know all of this to understand who we are, and this bit. Oh, not a very helpful program to click on things. And this is people who just don't quite get what we're about by reading the first bit. Yeah, because it's not simple. If you're a first-year architecture student and you've never thought about free software issues and proprietary vendor lock-in, that's a big deal. That's a lot of stuff to digest, you know. Yeah. It is a lot to digest, in my opinion. I still think there's also, and I'm sure we could find among us lots of discussions about which license is best and why and all of that. Yeah, the other points there, I think we can. Yeah, I'll just say that I think it'd be great if we can, at some stage, begin collecting some eye candy, as we called it at my architecture school. I don't know if that's still a popular phrase. And that was because I wrote to one of the BIM organizations here in Aarhus who are very active, and realized that I didn't really have a page I could link to that she would appreciate. So a page that has some great graphics.
This would be the OSArch main website, correct? Which would have fancy graphics of FreeCAD and Blender and Codaster and all of the hundreds of toys, Cesium and OSM.
And at the moment, I notice you've chosen to leave that empty. You know? Interesting. There's nothing there yet, right? At the top of the main. But yeah, that's what I'm talking about. That needs a page where people can have a look. For some very interested in getting some architecture students involved, because I think that but they have the time and resource, and they're connected to a whole institution which has even more time and resources. So that's part of why I think that would be interesting.
Yeah, if somebody puts together a mock-up and says like, okay, here's the mock-up, and in order to achieve it, we'll need a screenshot of this program, a screenshot of that program, we'll need some boiler text written for this, or here's just the basic page structure. You know, we won't have an about page, and on it we put this, and we link to we have a navigation which has a link to the wiki and the community forums. It's just something basic. It doesn't have to be big. If somebody could just mock that up, I'd be happy to build it. And then we can just say, okay, for the FreeCAD one, Yorick can provide a screenshot. For a Blender one, I'll provide a screenshot, and for a Codaster one, Ioannis will provide one, and all that type of stuff. So, that sounds.
I'm sure we'll get there.
Yep, and I see.
Think it would be,
Somebody started talking.
Oh, yeah, Ryan. I think it would be a cool idea, Dion, or the group here. Well, for this opening, for this free MVD project, we're round tripping various content. We started a OSArch GitLab repo for the group. So that'd be kind of maybe a way to upload actual physical projects, not just eye candy, but actually projects that have demonstrated one thing or another that people could download and play with and, you know, mess around with. That could be one place to put it.
I think as well that interest in this kind of thing I'm imagining would really start to accelerate when you can have sample files that people who've got the time and the inclination can open and start playing with, and you've got workflows like you guys have been working on where they can say, oh, okay, so if I sculpt this thing in Rhino, then I can take it into this program and do something smart, and then I can take it over here and do something smart. When we start showing those, then I think we're really getting the ball rolling in some schools of engineering and architecture.
Yep. And the beautiful thing about Git too is that, you know, it shows those snapshots of progress throughout a project's evolution, right? And so that in and of itself is educational to somebody to say they can actually go through how has this evolved over time, not just the final product, you know.
Yeah, see, there's a global citizen has a good point in the chat there. It's also catching these really simple use cases, like if you can quickly throw up a model and locate it in your geography and see where the shadows are. That's the sort of thing they could spend an awful lot of money getting someone else to do. And that's this thing of sort of democratizing the process. Yeah.
I only mention that because I've just done that. So
yeah.
I was really impressed at how good the open source stuff was. And the next challenge is getting sort of drawing output. I've already done it through like tracing in a vector program, but now I was really amazed to discover both Dion and Kevin's work, being the Blender BIM add-on and the Measured Arch add-on, both of which now seem like they're viable options in that space. Or we're on the threshold of establishing something that is not for perhaps, you know, hyper detailed engineering or construction drawings, but for, you know, basic planning stage drawings, far more than adequate and capable of use by the general public. I just think it's amazing where it's at. So the discussion that Dion was mentioning a little bit earlier that sort of we've begun to have in the last week or so was around maybe how to share the pain points between the various attempts to resolve them at the moment, and maybe come up with a considered approach that uses the benefits of some of the existing projects and sort of has a path forward that doesn't involve 3 or 4 people starting from scratch on their own attempts to resolve these issues. And I think I actually made a list. One of the issues was dimensioning. One of them was you know, being able to generate the drawings as output. And right now, Dion's work is fantastic. It's got, you know, almost all the features in there already, but it also needs polish, and the UI is, I think if Dion would agree, it's a little bit challenging for out of, you know, well, for anyone really. So yeah, I was really keen if we could maybe take the discussion in that direction. Dion, you began. What would you like to say?
I wouldn't want to continue too much in this chat because we are approaching a long time. Just because people who missed this meeting, I don't want them to have to sit through 2 hours of a YouTube recording. It gets a little bit long. So we'll continue this on the forums, and I'm sure that, and maybe we just Kevin, you and I can, and Stephen as well, can meet up independently to work things out.
Okay, sounds good.
Yeah.
But back to the creating a night, because that was on the agenda before, creating some eye candy. Is anybody interested in taking the lead on that one and doing a little bit of a mock-up? Doesn't have to be fancy, just even bullet points, a scribble, or say it looks like this, has this nav items and so on.
Yeah, I was wondering, Mold, if it might not. I haven't done any complicated websites for a while now, but what's the easiest way of doing it? Just a quick mock-up in in GIMP or something to show a layout or what?
Yeah, just the layout. There doesn't have to be much design behind it because that will just occur as a result of the content.
Because I think there's a few interesting issues in it. Like what do we want? What do we want to? I'll try and do some hand sketches just to show some ideas, because I think there's also do we want to showcase a couple of different tools? That would be one way of doing it. Or do we want to showcase some workflows so we maybe don't show very much of what tool is involved, but we show what sort of processes are involved. Because we don't want to be a software store which says that these 3 programs are the only way to do it. It's sort of a bit of a hole I'm a bit concerned we could easily fall into. Because when you look at our software directory, there's a lot to choose from.
Yeah, that's right.
So as soon as you start having pictures of some of them, and then you want to have some pictures of another one as well, you can't. It's sort of a bit difficult to say no. So I'd hate to start a disagreement on something silly like that. But
I think that you have to somehow mention also the software, because people then will start asking, okay, I like this, but how I can do it? So I don't know.
Sure.
Maybe it can
What
be
I'm
also.
trying to do,
Yeah.
What I'm trying to think in my head is one page before you start clicking on things. What do we want to have there? Because of course, as soon as you start clicking on things, then you go down and you say, oh, this picture comes from this workflow where we've used FreeCAD, and then we've done this and done that. I'm trying in my head to picture something for the very short attention span 17-year-old first-year student.
Yeah, I mean, I don't know. I think maybe it could be also both. Maybe that you have, let's say, some pictures or some visuals for software, and then I also like the workflow, let's say, concept. That can be also interesting, where you just mention the tools that were used. I don't know.
I might try and sketch something. Somebody else might. I'll probably get distracted and busy with something else. But now we've talked a little bit about some ideas of how to do it. Let's see who has time. Because until we have those workflows, this doesn't make a huge amount of sense to spend a massive amount of time promoting them.
That's also true. We need to, when this stuff becomes a little bit more polished, there needs to be a lot more videos and documentation, and all that needs to come.
Yeah, but I think at the moment, I think it is sort of, the reality is we do have a few flagship products, and that's just how it is at the moment, and that's fine. Deanne, I was wondering if we could talk about format a little bit here, whether we want to, like I set up a page and wrote some points in for an agenda. Do we want to do that each time and sort of close the list on the day? Do we want to say that we try and aim for an hour and a half, or is 2 hours great?
Yeah, maybe just. I only have a preference for under 2 hours, simply because it gets a little bit long. But other than that, I think it is good to start with one structured, like, presentation, and then the rest can be sort of free form, kind of like how I've enjoyed doing it that way. Others are free too.
I'm kind of asking because I started writing some points on an agenda, and I don't want to presume to do that if people don't like that way of doing it. But I thought maybe there are those 3 things. We've got a presentation, we've got some points we've agreed to talk about, and then anyone can just add other topics that they would quite like to talk about. And if some of them turn out to be important, well, then we need to bump them up the list for the next meetup.
Yeah, I like that approach. An agenda, a keynote, and then some action items and then discussion items in that order.
Yeah, let's try it. Let's try it. I just think it's really great that people can see what the topics are. So if they want to stay after the presentation, they can, and if they don't need to. And if they want to go back and see one from an earlier time, they can see what it's about. But if people don't object to me trying to put a little bit of structure in, then I'll do that until someone feels a bit straitjacketed.
I think it's fine. You have all the freedom.
I'll put another list there for next time, and then as people are inspired to suggest topics and all of that, and we'll just keep adding it in.
I just wanted to say, because let's say, I kind of had said that I would talk also about IFC to Codaster, and it didn't happen. So I will prepare a video where I will, let's say, show how you can create the files and how you can run in Codaster, and then I will put it in the forum. So at least, because some people maybe wanted to see it, and I'm sorry that it didn't happen, but I will make a video about that.
And so Yorick definitely wants to see that.
Yeah.
Don't know about other people's time zones, but it's 1:45 here.
Yeah. Okay. Should we wrap this one up?
Yep. I also posted real quick the GitLab OSArch GitLab spot. If anyone's curious where it's at, or that's where that free MVD workflow is posted. So just logging it.
Cool.
Yeah, we can probably migrate a couple projects there, like the classifications database and the test files repo.
Cool.
We've talked a little bit earlier about some example projects. I've got a little addition to my house that is going to be a few years before it gets anywhere, which I'll try and do with all of the software. So I'll bring it into the forum, and we can talk about what parts of the project could be interesting to do, because there's all sorts of daylight simulation and beam calculations that could be interesting. It's just a little addition to our house. I think someone else, who was the other person who mentioned a similar project? Somebody else mentioned a similar project.
That was me. So helping out, doing some little, you probably saw this little stair documentation that I did. Those were some stairs which are being built, but they're ready in fabrication now, so it's basically almost finished. I think now there's a bit of work to be done on a retaining wall somewhere, but I don't know any more details yet. I'll chase that up.
Cool. I'll do what I can to document my one, because I'm right at the bottom. I'm a competent Revit user, super user for Revit, but I haven't managed to do the Blender donut yet. So I got my 14-year-old to learn how to use Blender first, so he's going to teach me. Cool.
Those are the dividends of having children, right?
Yep, he's much more patient. He can spend days on it. I don't have days to spend learning it.
Yeah, exactly. I actually tried to turn my daughter on to Blender 2. She's 10, so she wasn't having it. We'll have to wait a couple years. Well, cool. Should we wrap it up?
Yep.
Yes.
All right. Do you know what they say, that it's beer 30 or 5:30 somewhere in the world? Right now in Wisconsin, it's 5:30. So
it's beer time in Wisconsin.
Yes,
bedtime here.
All right, guys. Cool.
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 I
Thank
gotta
you,
go.
everyone.
See
Thank
you
you
then.
all, guys.
Thank you.
Yep.
Bye bye.
Bye.
Oh, that's great.
Bye
Thanks,
bye.
everyone.
Bye.